Hello students, today we are going to start our first topic from 8th standard and the name of the topic is rational numbers. Before proceeding to see what are actually the rational numbers or what kind of numbers are called rational numbers, let us do a quick recap of what are the different kind of number systems which you have learned until now. Let us begin with the basic number system, that is the numbers called as natural numbers. So the numbers starting from 1, 2, 3 till infinity are categorized as natural numbers. All these numbers are positive. Now, when you add 0 to this set of natural numbers, the numbers so obtained are called as whole numbers. So if you try to represent it in terms of a set diagram, so suppose this is the set of natural numbers, the whole number set will be above it since it includes one more number other than the natural numbers. Now, in both the cases, I haven't represented the negative numbers. So, if I have to include the negative numbers also in this set, the set so obtained is called as integers. Okay, so a set of negative numbers 0 as well as positive numbers are called as integers. So now where will this be represented in our set diagram? It will be including natural numbers, whole numbers, and also some another negative numbers, hence they are called as integers. Okay, so this you have learned until now. Now if I say all natural numbers are integers, is it a statement true or false? Yes, because each and every element of natural numbers is definitely a part of integer. But if I say all integers are natural numbers, will that statement be true? No. Why? Because in integers there are negative numbers also which are not part of the natural numbers. Okay, and hence a integer set of integers is a bigger set compared to the natural number set. Now let us see what are rational numbers. Now here in all the three types of numbers, you didn't represent a number which are fractions. Okay, all the numbers were a complete number or you can call it as a whole number. But what if I have to add 2 by 3 in my set? In all the three categories, we can see that we were not able to represent such kind of numbers. Okay, so that becomes our next set of numbers called as rational numbers. Let us look at the definition. The definition of rational number says any number which can be represented in the form of p by q are called as rational numbers. Okay, so the definition also includes two more conditions. Now what are the conditions? The condition says whenever you are representing any number in the form of p by q, both p and q has to be integers, whereas the value of q cannot be equal to 0. Okay, so now let us try to explain, try to understand what this condition means. Coming back to our example, 2 by 3. Now, is this a rational number? Let us go by the definition. It is in the form of p by q. Yes, the first condition says both p and q has to be integers. Now, as just now we have seen the set of integers. Is 2 an integer? Yes. Is 3 an integer? Yes. The second condition, q should not be equal to 0. Yes, the denominator is not equal to 0. So definitely this is a rational number. What if I write it like this? Minus 2 by 3. Again, is minus 2 an integer? Yes. 3? Yes. And the denominator is not equal to 0. So again this is possible. What if I write 2 upon minus 3? Again 2 is an integer, minus 3 is also integer, and the second condition is also satisfied. Which means that in case of a rational number, both the denominator as well as numerator both can be negative as well as positive. There is not any condition that the number has to be positive or negative. But let us try to see what this condition is. For example, suppose I write a number like 0 by 5 and another number like 5 by 0. Now, from these two numbers, I have to see which of the number is an rational number. Coming back to our definition, p and q has to be integers. Is 0 an integer? Just now we have seen all the whole numbers are integers. So 0 is a part of whole number, hence definitely it is an integer. Is 5 an integer? Yes. Is 5 the denominator not equal to 0? Yes. So this is an rational number. Actually 0 upon anything has the value 0 itself. Okay, so even if we write it like this, its final value is 0. What about this? P and Q has to be integers. Now 5 is an integer, as just now we have seen 0 is also an integer. But the second condition says the Q should not be equal to 0. Even though in the first condition they have specified that Q has to be integer, but there is one exception to it. What is that exception? You can take value of Q anything except 0. Why? Because if you take the value of Q as 0, you will get a number like this, and such kind of numbers are actually not defined because we cannot find the value of such kind of numbers, right? And therefore such numbers are not defined. Hence, if I didn't consider this condition and I only follow the condition that P and Q are integers, even this example is also possible. But such numbers are since not defined, hence the second condition specifying Q should not be equal to 0 is equally important. You can take value of Q any number except 0, because then you will get a number like this, which is whose value we cannot find. Okay, so I hope you understood what is the definition of a rational number, where P and Q are integers and Q cannot be equal to 0. Now let us see how to represent these numbers on the number line. You already know how to represent natural numbers, you already know how to represent integers on the number line. Let us see how to represent the rational numbers. Let me draw a number line first. Okay, so this is my 0, 1, 2 on the right sides, whereas the negative numbers on the left side, right? If I have to represent only natural numbers, my number line would start from here, so only the positive side. If I have to represent the whole numbers, my number line would start from 0, and if I have to represent integers also, so this will be my number line, right? Now the same example, let us see how we can represent 2 by 3 on this number line. Okay, so the question says 2 by 3 is a fractional part, right? So it will be including between any two numbers. Now in which two numbers they are including, that we have to see. Also, even in that two numbers, where exactly the location is. The steps for representing rational numbers on the number line says whatever number is present in the denominator, that many parts you have to make of each unit. Now what is meant by unit? 0 to 1 is 1 unit, whereas 1 to 2 is 1 unit. Similarly 0 to minus 1, minus 1 to minus 2. So this each sections are actually 1 unit. So the number at the denominator specifies how many parts of each unit you have to make. Since here the number is 3, it means I have to make 3 parts of 0 to 1. Similarly, I have to make 3 parts of 1 to 2. So let us make 3 parts. So 1, 2. Even though you are saying 3 parts, but ideally you are making only 2 lines. Now that parts are also should be equal parts, meaning you cannot draw the first part here and the second part here. Are they equal? No. The parts which you are making, they have to be equal in length, right? So since here the number is 3, I have made 3 parts, though it says 3, but I will be making 2 lines. Why? Because then ideally I will be getting 3 parts. So this is my first part, this is my second part, and this is my third part. Similarly, between this unit also, 1, 2, so again 3 parts. Each unit has to be converted into 3 parts. So this becomes my first step. What is my second step? The second step says the number which is present at the numerator, that many parts you have to count or you have to consider. Now since the number in the numerator is 2, it says I have to count only 2 parts. Now my first part, will it begin from 0 or will it begin from this number? Is this a first part? No, the first part begins from this line. So your counting should also start from this line, right? So as the number is 2, so I will count 1, 2. So the number 2 by 3 will be present here. What if I say I have to represent 5 by 3? Again, since the denominator is 3, so I have to make 3 equal parts. So my parts will be same, only the number at the numerator has changed, so I have to count that many parts. The number present in the numerator is 5. It means I have to count 5 parts. So my first part, second part, third, fourth and fifth. So here will be my number 5 by 3. Similarly, if the number would have been minus 5 by 3, you would have made the same parts on the negative side. Let us make, so 3 parts, again 3 parts. The number present in the numerator is minus 5. So leaving the minus sign, just count the number, that is 5 on the negative side. So 1, 2, 3, 4, 5. So my minus 5 by 3 will be present here. So this is how you represent the rational numbers on the number line. First step, divide each unit into equal parts. Second step, the number present in the numerator, that many parts you have to count. Always the counting starts from the first part, that is, don't include the zero number in your first part whenever you are counting. Next example, suppose I have to write 4 by say 6. Okay, so what I can do, so instead of writing 4 by 6, let me write 1 by 6. Okay, so here how many parts I will make of each unit? 6 equal parts. And how many parts will I count? 1 part. So this is how the representation of rational numbers is done on the number line.